towering waves born from underwater disturbances, have long wreaked havoc on coastal regions, obliterating everything in their path. Unlike regular ocean waves that are generated by wind, tsunamis are caused by seismic activity, underwater volcanic eruptions, and even asteroid impacts. These waves are not just surface ripples. They carry immense energy, moving at speeds comparable to jetliners, and can rise to over 100 feet when they reach shallow waters. Their sheer power can reshape coastlines, destroy cities, and claim countless lives. For naval vessels, these natural phenomena present a unique and formidable adversary. Unlike civilian ships, which often find themselves in vulnerable coastal areas, naval vessels are built with military-grade engineering and strict emergency protocols. However, history offers sobering tales of ships caught in tsunamis, highlighting the risks and challenges faced by even the most formidable fleets. Historical encounters, when tsunamis took the Navy by surprise. One of the most striking examples occurred in 1868. The USS Wateree, a gunboat anchored off Arica, now part of Chile, faced an unthinkable ordeal when a massive earthquake struck. The subsequent tsunami lifted the vessel and carried it nearly half a mile inland. When the waters receded, the ship remained marooned on dry land, stranded, battered, and utterly useless as a naval asset. It was a stark reminder that nature's wrath could overpower even the best-built vessels of the time. Fast forward to December 26, 2004, when the Indian Ocean tsunami, triggered by a 9.1 magnitude earthquake, unleashed unprecedented devastation across multiple nations. The tsunami didn't just impact civilians, it also forced naval forces worldwide to rethink their strategies. Ports were destroyed, coastal bases were flooded, and ships anchored too close to shore suffered significant damage. The disaster prompted military strategists to revisit their protocols for tsunami response and preparedness. These historical events underscore a critical reality. While ships may be designed for combat and extreme weather, tsunamis introduce unique challenges that require specialized strategies and structural reinforcements. Engineering marvels: how Navy ships are built to withstand nature's wrath. Modern U.S. Navy ships are not just built for warfare. They are engineered for survival against some of the most extreme forces on Earth. Their ability to endure violent storms, rogue waves, and even tsunamis comes down to three key design elements. 1. Reinforced hulls. The outer structure of a naval ship is designed to withstand extreme external pressure. Unlike civilian vessels, which prioritize cargo space and efficiency, naval ships prioritize durability. Their steel hulls are built to absorb impact without compromising structural integrity. 2. Advanced stabilization systems. Unlike smaller boats that can be capsized by large waves, modern warships are equipped with advanced stabilization systems. These include ballast tanks that adjust water levels to maintain balance and gyroscopic stabilizers that counteract rolling motions in turbulent waters. 3. Watertight compartments. One of the most crucial features of naval vessels is their compartmentalized structure. In the event of a breach, watertight doors seal off affected sections, preventing widespread flooding. This design ensures that even if one part of the ship sustains damage, the rest of the vessel can remain operational. However, even with these advanced features, no ship is invincible. That's where strategic preparedness becomes critical. Strategic response: the Navy's secret weapon against tsunamis. Surviving a tsunami isn't just about having a strong ship. It's about being in the right place at the right time. Unlike hurricanes, which provide days of warning, tsunamis can strike within minutes of a seismic event. This makes rapid response and early detection crucial for naval survival. When seismic activity hints at a potential tsunami, naval protocols dictate swift action. The first move? Get to deep water, fast. Here's why. In shallow coastal areas, tsunamis grow into massive, destructive walls of water. However, in deep ocean waters, these waves remain relatively low in height, sometimes only a few feet tall. A warship positioned in deep water will barely feel the impact of a tsunami, as the energy of the wave is spread out over a vast distance. The key is to avoid being near shorelines, where the wave gains its destructive power. To facilitate this response, the U.S. Navy relies on a combination of seismic monitoring systems. Global networks of seismic sensors detect undersea earthquakes and assess their tsunami potential within minutes. Tsunami early warning systems. These systems use deep-sea pressure sensors to measure abnormal wave activity and predict tsunami formation. Rapid mobilization protocols. Once a tsunami threat is identified, naval vessels stationed near shorelines are ordered to relocate to deeper waters immediately. This proactive approach has allowed the U.S. Navy to avoid catastrophic losses in recent decades. But what happens when evacuation isn't an option? Real-life survival, when preparedness pays off. Consider a recent incident where a U.S. Navy vessel, alerted by seismic reports, promptly relocated to deeper waters. The crew executed their training flawlessly, navigating away from potential danger zones. When the tsunami arrived, the ship rode over the waves with minimal impact, proving that strategy and preparedness are just as important as structural resilience. Not all vessels are lucky enough to be in deep waters when a tsunami strikes. Ships docked at naval bases near tsunami-prone regions must rely on rapid response measures. Reinforced moorings, emergency flood barriers, and elevated infrastructure all play a role. Beyond survival, the Navy's role in tsunami. Aftermath. Surviving a tsunami is one thing. Helping others recover from it is another. The U.S. Navy plays a crucial role in disaster response, often being the first to provide aid after a tsunami devastates a region. The Navy's ability to quickly mobilize resources and deliver assistance to areas in dire need is a testament to its global reach and operational flexibility. One of the most significant examples of this was Operation Tomodachi in 2011. Following the catastrophic earthquake and tsunami in Japan, U.S. Navy forces launched a large-scale humanitarian mission to deliver aid to affected areas. Aircraft carriers, hospital ships, and destroyers were deployed in record time to provide food, medical supplies, and search and rescue teams. These assets were essential in supporting local authorities and ensuring that aid reached isolated communities. The mission demonstrated how naval preparedness goes beyond self-preservation. It extends to global humanitarian efforts. It also showcased the Navy's unique ability to combine military and humanitarian objectives, leveraging advanced technologies, medical expertise, and logistical support to save lives and assist in long-term recovery. By coordinating with international agencies and local governments, the Navy's response helped to stabilize the region and bring hope to those affected by one of the most devastating natural disasters in recent history. The future of naval tsunami preparedness. The lessons learned from past disasters have shaped modern naval strategies, but new and unforeseen challenges continue to emerge, pushing the boundaries of what the U.S. Navy must prepare for. As the world faces rapid environmental changes, the military is forced to adapt its strategies and technologies to maintain its dominance in maritime warfare and safeguard its personnel, ships, and assets. Climate change is contributing to an increase in the frequency and intensity of extreme weather events, while seismic activity remains unpredictable, complicating efforts to safeguard naval operations. These challenges require innovative approaches, and the U.S. Navy is at the forefront of developing cutting-edge technologies to stay ahead of these environmental threats. In response to these evolving dangers, the Navy is investing in several key areas. Enhanced AI-powered prediction models. Artificial intelligence is now playing a crucial role in analyzing seismic patterns, weather systems, and oceanic conditions. By leveraging AI and machine learning, the Navy is improving its early warning systems, ensuring that personnel and vessels can respond faster to incoming threats like tsunamis, earthquakes, or storms. These predictive models enhance situational awareness, giving Naval Command the ability to make faster, more informed decisions during critical moments. Next-generation ship designs. In an effort to combat the increasing severity of oceanic forces, the U.S. Navy is experimenting with innovative ship designs. New hull structures and materials are being tested that provide even greater resistance to extreme weather conditions, such as powerful waves, rough seas, and other maritime challenges. These designs aim to enhance the Navy's ability to operate in all weather conditions, minimizing the risk posed by Mother Nature and maintaining operational readiness regardless of environmental hurdles. Improved coastal defense infrastructure. The Navy is focusing on strengthening its coastal defense infrastructure, especially in areas prone to natural disasters like tsunamis and hurricanes. Naval bases situated in these vulnerable regions are being reinforced with better flood mitigation systems and advanced technologies designed to minimize the impact of rising sea levels and extreme weather events. This proactive approach ensures that critical infrastructure remains intact,